Welcome back. Today we're going to talk about compound interest. This is truly the machine that drives the interest craze. Compound interest is where we make our money, because compound interest is not only calculated on what you initially had or borrowed, but it's compounded because you calculate simple interest and then you calculate interest on that total value with interest. And so it looks like this. Principal. And when we do interest, when we do compound interest, it looks something like this. It'll be, principal, add interest. Well, then we have principal plus interest 1. So this is interest 1. Well, then what we do is we calculate interest on principal plus I1. So we get P principal plus interest 1 plus interest on that value. And this is why it's compounding, because then we're going to say our total becomes principal plus interest 1 plus interest 2. Well, then we calculate the interest on that. And so you see how this goes. We continuously have a bigger amount that we're calculating the interest on. The compounding period is where we make our money. The compounding period is how many times or how often we compound. Okay? It's how often we compound. Common compounds are annually, one time per year, semi-annually, two times per year, quarterly, 4 times per year, monthly, or daily. We're going to come back to what that actually means in a second. So when we calculate the future value, we need to figure out what exactly we're going to be looking at. We deposit $500 in an account earning 6% interest compounded semi-annually. How much is the account at the end of 1 year? Well, if we look at what this actually means, we have a couple of ways that we look at this. How does it work? Well, let's think about this logically. First time. So the first time that it's compounded, we calculate the simple interest. So we have interest equals principal times rate times time. And so interest equals 500 times rate. So it's 6% interest semi-annually. So our time period is going to be 6 months. So that's going to be 6 out of 12, because remember, our interest rate is, a year, because we're assuming annual interest. And so that equals interest, which gives us $515. So 15 was our total. So P plus I equals 515. Well, that's after the first time. That's the first time. The second time, we take P equals 515, because remember, this is compounding. And so the next time we have interest equals PRT, and it equals 515 times our rate is still the same, 0.06, and our time period is still that 6 over 12. So at the end of the second time, we end up with $530.45. We calculated the simple interest once, then we compounded it and calculated the simple interest on the amount that we had at the end of the first time. So here's the second time. All right, so that's how compound interest works. You find the simple interest, add it all together. Then take the simple interest of that, add it all together. Let's look at this next example just to see if we see how it works. If you want to pause it here and try it, that is okay. That would be more than fine. It would be perfect, but you can check your sample answer when you get done. First time. Well, we need to know how far we're going. We deposit $2,000 in account, 4% interest, compounded monthly. Okay, so when we compound monthly, it's going to keep going and keep going and keep going. Okay, how many times? 6 times. So the first time we say interest equals principal rate time. Interest equals 2,000, 0.04, and it's an annual interest rate, so we have 1 out of 12, right? And when we calculate that, let me get out my calculator here. Okay. Let's see, 2,000 times 2,000 times 0.04 times 1 equals $6.67. So that's how much interest we earned the first time. So principal now equals, so this is second time. Principal equals $2,006.67. So interest equals $2,006.67 times 0.04 times 1 over 12. And what do we got here? Let's see. 2006.67 times 0.04 times 1 divided by 12 gives us $6.68. Actually, it's 69 cents. So you see how this works. So now our principal is 2,667 plus $6.69. So I'm going to add that to plus 2006.67. So my new principal amount is 2,000. This is third time. Principal equals $2,013.36. You see how this interest starts to rack up? All right, so interest equals 2,013.36 times 0.04 times 1 over 12. And just think, we're only doing this 6 times. Imagine it was compounded continuously. So I'm going to take that answer, multiply it times 0.04, and times 1 divided by 12. And I get my interest is $6.71. Well, that goes on to our total. So plus 2,013.36, $2,020. Okay, and so that becomes the amount for our fourth time. You see how this works. Finish that example. Finish that example. Compound amount. The compound amount is how much we end up racking up over this whole time. And the formula is A equals P times 1 plus I to the N. What does that mean? A is the compound amount. That equals the total. That's the compound amount. And P is the principal. I is a little bit different. I is actually the annual interest rate over the number of compounds. I'm going to scroll up here. The number of compounds per year. So that's how often you compound it. And N is equal to the number of times per year times the number of years. Okay, so A is the total amount that we're going to get. P is the principal again. I is the annual interest rate over the number of compounds per year, and N is the number of compounds times the number of years, the total number of times you're going to be compounding this. Okay? And so that is where we're going with this. Let's do an example. An account that earns 12% interest compounded quarterly for a period of 3 years. Well, what would it look like? We would need to find I, which is equal to annual interest rate over number of compounds, and that's per year, and that's going to equal this. The annual interest rate is 12%, okay? And so we're going to put 12% over the number of compounds per year. Well, if it's compounded quarterly, that's 4 times per year. So this is our interest rate, or our I, which is 3%. N is going to equal the number of compounds per year times the number of years. Okay, and so that's going to be equal to 4 times 3, which is 12. So we're compounding a total of 12 times. All right, and so that is the basis for this. So N equals 12, I equals 3. All right, that's how this works. So we plug all that stuff in, and we find a couple of different values that we need in order to solve this formula. Here's a little chart. Annually, N equals 1. Semi-annually, 2. Quarterly is 4. Monthly is 12. Daily is 360. All right? Let's do an example. Let's use this formula. Compound amount. 10,000 is deposited into an account, earning 8% interest, compounded semi-annually for 4 years. This is a realistic situation. So A equals P times 1 plus I raised to the N. I equals, now I is the rate, 8, over the number of times per year, which gives us semi-annually, which is 2. So this is 8% over 2, so that's 0.08 over 2, which gives us 0.04. All right? And N is equal to semi-annually, which is 2 times 4, because it's 4 years, N is equal to 8. So let's plug this in. Our amount is equal to our principal, 10,000, times 1 plus, here's our I, 0.04, times raised to the number of times, raised to the 8th. Okay? So when we do this math, we are going to do 10,000 times 1.04 raised to the 8th. When we use our order of operations, we do 1.04 raised to the 8th. That gives us 10,000 times 1.368566905. And I'm going to multiply that by 10,000. And I get $13,685.69. That's the power of compound interest, guys. Power of compound interest. Right there. Compounded a bunch of times, we start to get a huge amount racked up. That's 4 years. We got almost $4,000 more dollars. All right? Knowing what you know about future value. Okay? I want you to try B, C, and then I want you to try B, A, B, and A. All right? So try these 3 on your own. And that's where I'm going to leave you. Try these 3 on your own. Remember what it means to have future value. Remember what this formula is. See if you can do this on your own. All right, guys? Come to class with questions. I'll be checking those notes. Let's check it out. All right? We'll see you next time.